from carry in from back side. AB is 0, 0, then carry in is 0, then output sum is 0 and carry out is 0. But when A and B is high, then both is high because of carry 1, C out 1 and sum is 0. But when Cn is 1, if either A or either B is 1, then carry is 1, otherwise is 0. But when A and B is both high and carry is high, then all things C out and sum is high. Has the logical equation of sum is equal to A XOR B XOR C in and carry is equal to A XOR B into C in plus A and B. I have designed a lot of full adder using transistor level, so that's the reason I just explained what I have done, what I have achieved. Energy efficiency, because main target of my research, my work in electronics engineer, main target is energy efficient should be low, power consumption should be low, and speed should be high. I have designed for low power consumption. I'm using hybrid logic design. Hybrid logic means there are lot of techniques, CMOS based, past transistor logic based, and transistor logic based. All things has been combined in one adders. Eitherly previously lots of people are also working, researchers also work either CMOS based, either past transistor based, either transmission logic based. Main issue is CMOS based is power consumption high because of charging and discharging value is high. So that's the reason power is high. Past transistor logic issue is threshold issues, threshold drop, and I'm using hybrid logic based means past transistor logic, CMOS, and transmission gate. All things has been combined. That's the reason. And one also achievement, I'm using parallelly XOR and XNOR. I will explain in next slide. So that's the reason my power consumption should be low. The purpose design parallelly XOR and XNOR signal. This is the reason power consumption I have reduced for using XOR and XOR signal parallelly. Key specification parameters of electronics engineer, not for this work, VLSI design, your power consumption should be low. Speed should be high, delay should be low. Power delay product means energy consumption should be low and area should be low. If area should be low means your critical path also low, your complexity low means your power already should be low and its speed should be high. I have explained four designs, just I have purpose, and it will be benefit for you. And just like as you are VTech and MTech student, you can utilize, gain these things, and after implement your research and your project, it will be very easy to understand. Here is block diagram of and truth table. Truth table I have already explained. Block diagram, just you are parallelly design XOR and XNOR, then it will be power should be low and speed should be high. Here is A and B using for XOR and XNOR. Have you familiar with XOR and XNOR? Hello, Dr. Tilak? Hello, am I audible? Hello, am I audible? Dr. Suresh, am I audible? Hello? Why you are not good? Hello? Oh, yes. Okay, thank you, thank you, thank you. Yes, these are the module I have proposed. Just listen.
Sir, audible.
Module yes, 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 yes.
Hello.
Okay. Yes, yes, yes. I have seen message.
Hello, sir, audible.
Yes, 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 yes. Thank you. I have proposed XOR and XNOR circuit in parallelly, XOR gate and XNOR gate. Because of parallelly, there is not any inverter delay and not dependent stage. Just like as if XOR and XNOR is dependent, means XOR and one inverter stage after XNOR, then delay will be high. So I have reduced XOR and XNOR parallelly.
చెప్పండి.
That's the reason speed should be high. Okay, and I'm using for some transmission gate based 2 cross 1 mux and carry junction circuit module 3. This is the test bench used for VLSI circuits, for SRAM circuits, or all memory circuit. You can use just like as ABC input circuit under test. You have test your circuit and your output. You have get FO4 load for output, 4 inverter in parallelly, and input. You have taken two inverter buffer because of glitching issues, and also if your carry and sum is not fully drive, then it will be beneficial. You can use two inverter buffer. This is the netlist you can use if you are using HSpice or LTS Spice. I think PS Spice is not used for this circuit. This is used just like I have using FinFET 16 nanometer and CNFET 32 nanometer. You can use in other instead of 16 nanometer, you can use 22 nanometer, 7 nanometer, all model you can use. After that, you have generated circuit netlist. After you are using HS5 simulation, then will get final results. Same process for ternary circuits. You are using CNFET model 32 nanometer and circuit netlist HS5 simulation final result. But if you are use Cadence Virtuoso or different tools, then this method has been changed. You need to generate a schematic instead of circuit netlist. After generate a schematic, then you will finally get the result, and after get the result, you will draw the layout of the circuit. This is my circuit. I have just explained briefly. If you need explaining more, then I will explain. Just like as I have explained, I'm using parallelly XOR and XNOR circuit. I published this work in IIT circuits, IIT journals for Wiley publications in 2K21. Here I am using XOR and XNOR parallelly. If you need, I will also explain working of this circuit, then it will be easy to understand circuits. If you need, you can send the message in comment section. I will explain working. Otherwise, I will just explain in brief. Here is just I'm using one inverter A, and then XOR and XNOR I'm using. For carry, same thing using for carry only seen inverter and output gate from this side. And for sorry for sum and for carry out, I'm using four transistor. All things are in parallelly, and XOR and XNOR generate parallelly. So there is no dependent, no feedback for XOR and XNOR generation. If feedback is generation, then delay is more because output CO depend first XOR and XOR is dependent XNOR. So there is not any stage of delay. That's the reason this circuit will be fast. Here is full swing path XOR and XNOR. If you will say and if you will message in comment section, then I will explain in uh, all circuit working and truth table. Otherwise, I will just skipping those things. Here is all the working of XOR and XNOR. Which path is full swing, which path is not full swing, I will explain. Just like first circuit, I am explaining in for briefing just. Here is B and A. You know very well, I think, NMOS is pass 0 logic and PMOS is pass 1 logic. But for input, for PMOS is operated 0 and NMOS is 1. Just like as working and explained briefly, for XOR, A is 1. P3 is pass only A is 1 for good logic. A is 1 means and B is 0. Then this time P3, A is 1 and B is 0. Here is in truth table. This time this path will be on. Next time P2 when on, when B is 1 and A is 0, then this is pass a full swing path logic. Okay. Next for XNOR, where is A1, then B is 0, then output should be 0 because this logic will pass this one can only use for on and off. This is the gate voltage, gate value. B is 0 means P5 is on, B is 1 and 3 is on. But it will pass. If P MOS, then it will pass high 1, and if N MOS, then it will pass 0 logic. Okay? And then next move also sum and carry out using XOR and XNOR. I've already explained that XOR and XNOR is parallel. That's the reason my circuit will high speed getting. This is the timing simulation of B, A, C in. If B0, A0 and C in 0, then XNOR 1 when A and B is 0, or either A and B is 1, then XNOR will be high. Rest of the time XNOR will be low. Of course, XOR operation when either A is high or B is high at the same time, then XOR operation is high. Rest of the time it will be 0. But for carry out, A B 0, C 0, then C out is 0, and sum is 0. But if anything is 1, either A, either B, either C, then sum will be high. If both C and A is high, B 0, C 0, then sum is high but carry is 0. Carry only propagated when two logic will be high, either AB, either BC, or either ABC. Then carry will be high. Rest of the time it will be 0. This is the impact power voltage variation which you have used for research purpose. Same thing you will if you are BTech in second year, third year, just you have draw this circuit in tools H spice, LT spice, current battery. So it depends upon on your availability. After that, you will get power consumption. Initially, low voltage, there is low output voltage, and when voltage is high, then output voltage also high. Same thing true for delay. When you initially low voltage, then it means low current means charging and discharging time will be high. So that's the reason your delay will be high. When power will be high, then your output your delay will be low because current is high and charging and discharging time should be low. That's the reason your delay will be low. And same thing is for PDP, power delay product energy consumption. When input is 0, then input low, but when power is high, then output slightly it will be high. Okay. Same thing I will explain design parallelly XOR and XNOR in other another design, same working either A0, B0, then output will be high. This is the just I have explained transistor level I have using for full adder, and after that you will use ripple KD adder for A0, B0, same carry will be propagated. AB will be different, but carry will be dependent on previous stage. Just I'm explaining and full adder, just I have used parallelly XOR and XNOR, but here A and B is 0, 0, then carry is 0 propagated, but this C1 is generated by this full adder. A1, B1 is different, but this C1 generated previously, same C2 generated previously, same propagated at the end 32 bits. So if you are using simple full adder for any circuits like as FPGA and or any other tools you are using, then if you are using ripple carry adder, you are propagating to initial the C node C1, C2, C3. Also power delay analysis of this input. When power is low, then current is low, so that time your dynamic power is also low. But when input is voltage is low, but your propagation delay high because of this time low current, so charging and discharging time should be high. That's the reason your delay will be high at low power. But your PDP will always low at high voltage because of current value is also delay is also low and power is high, but delay is main dependent on PD. These are two, three, and also four example which have used parallelly XOR and XNOR base. And when I'm moving on ternary circuit, Have you familiar with ternary circuit? Anybody has work on ternary based circuits? Yes or no? In comment section, please reply. Otherwise, I am just thinking that you are not listening my voice. Anybody has worked and implemented any ternary circuits? Listen this now or not? Okay, then explain. Ternary circuit just like an I've just explained binary means only two. I've just explained binary means only two logic. Okay, but here is using I'm using three logic. Just listen carefully. Binary logic. Each word zero means 0 volt, 1 means 5 volt. Okay, digital logic you are using XOR and XNOR. Just I have explained. Means for low voltage, 0 voltage, zero logic, and for one means high voltage VDD. It depends upon your voltage supply. Maybe two, three, four. But this time I am working. We are working low technology node, just like a 60 nanometer, 7 nanometer. So VDD almost near about zero point 0.8, zero point 0.9, and 1 volt, but depend upon devices. Ternary logic. 0 means 0 volt, 1 means VDD by 2, middle length, and 2 means VDD high. Here is 0 means 0, 1 high, but there is a intermediate between the value. Just like as 0, 0 volt, 1 VDD by 2. If VDD 1, then 1 logic for zero point 0.5 voltage and 2 for 1 voltage. Multiple value logic means use 0 to number of n minus 1, but depend upon number of stage, just like as 3, then VDD by 2. If this is quaternary, then 0, 1, 2, 3. Here is 0 VDD by 2 VDD by 3 and VDD. Then number of stages is 4. It will be used for low interconnection. Means interconnection high, then it will be used for low interconnection. Okay. Okay. Here is multiple value logic exactly used. Reducing number of interconnection, decreasing the power consumption and propagation delay, increase the data. Just like as you are using 2 to power 8 is equal to 256. 256 means if you are using any data, any bit for transfer via binary logic bus, then you need to 256 wire 2 to the power 8 is equal to, if you are transfer 256 bits, then you need, sorry, 8 bit, then you need to 256. But internally, there is three logic 0, 1, and 2. There is 3 to the power 6 is equal to 729. Means you have sent the data same time 729, and here is 256. So 185% almost reduces. Just the reason I'm using ternary. Advantage mean more data in each digit, less circuit area, low power consumption, application, big data, embedded system, IoT device, and any digital circuits. Here is also example, here scale application on IoT internet using number of connected device several, but in binary you yes, Hari Babu Guruji. Okay, and also used for healthcare application and communication devices. Same using for memory, hexavalue logic, or different type of logic memory. You can use MRAM, magnetic memory. You can use this type of devices. And main advantage that we are using CN FET for multiple logic, because main advantage is that VTH threshold voltage is easily decided after using diameter. If you change the diameter, threshold voltage value will be changed. Main advantage to using CNFET technology, but it is binary. It will be tough because of low leakage current and all things. It will be tough. But for ternary, it will be easy to change the threshold voltage after changing the diameter. Diameter in CN FET either this type. Just like as for PCN FET using 19.0 means value of diameter 19, then your threshold value minus 2.89. If you're using 10.0 means diameter value 10, then your threshold value will be higher. Means your diameter value is less, then threshold value will be high. So that's the reason PMOS will work on 0 and 1 both logic. It will be more benefit also in for NC and FET, just like as I will explain again. For D1, threshold value is 0.289. This time PMOS is used on 0 voltage and for 1 voltage. 1 means 1 logic for 0.45 volt. But high voltage PMOS will be off in binary and ternary also. And for NCN FET, also using for high diameter threshold value will be low, then it will be on at logic 1 and logic 2. Then this is the main advantage to use ternary circuits for C and FET devices. Here is three inverter. Binary, I can say only simple inverter, but ternary using three inverter. One standard ternary inverter, second negative ternary inverter, and third positive ternary inverter. Means when your input is zero, means logic zero, then your output will be high. Binary also, when your input is zero, then output will be high. For NTI means negative ternary inverter, then your input is zero, then output is high, and PTI output high. But for mid value means logic 1 value voltage value is 0.45. Then your standard ternary inverter, normal inverter is 1 as it is, negative is 0 and positive is 2. I will explain circuit in next page. And for high value, STI is 2 and NTI is 0 and PTI positive terminal inverter is 0. Just this is the circuit diagram. You know very well in for binary inverter where input is 0 then output is high. Yes, and for same logic input is 0 just like as output high because for PMOS 0 it will be on and output high. But main advantage in ternary inverter when your diameter value, I will just say it here, when your diameter value will be high, then your threshold voltage will be low. Means your threshold value will be low, then your output will work PMOS 0 and band both technology. Just 0 and band both logic, just the reason your PMOS a positive terminal inverter is for 0 and 1, it will be on. For negative terminal, it will be off. Why? Because D2 means diameter is low. When diameter is low, then your threshold value will be high. That's the reason only it will work on 0. Rest of them, it will be 0. But for standard ternary inverter, it will be on because of it will be on because when input is low, then either this path, when input is high, either this path, rest of them VDD by 2 means output is pass VDD by 2. This is the waveform of ternary inverter. Here is transient in response of ternary inverter when all color I think is visible. When input is 0, then positive terminal output high. When input is 1, then output is high only for positive terminal inverter. And then when input is high, then all things is 0. Then output input is high and all things is 0. मैं बहुत स्लो तो ले जा रहा हूँ तिलक जी. हेलो. Am I very slow or very high speed? Same using ternary multiplexer, using 3:1. You have used. Okay, thank you. Same using ternary inverter, just like multiplexer you are using for binary. If S is control logic, if S is 0, then I naught is passed. S is 1, I1 is passed. S is 2, I2 is passed. Same using for 0 volt 0 logic, I naught 1 VDD by 2, I1 and for 2 VDD by 2. I'm using unary operators. Okay, thank you. I'm using unary operators. I've just explained PTI, positive terminal inverter, negative terminal inverter, standard terminal inverter, and also cyclic operator. Means your value will be move plus one, just like as two, then next stage one, then next stage two and zero. Means your value is supposed at zero, then positive cyclic operator x1 means zero plus one. If next two, then move to next one state. So this is the use of all cyclic operators. Maybe it will be tough time this time to explain all details, but it will be explained just ternary inverter using cyclic operators x1, x2 means you are moving this value, moving for plus one, then plus two, then plus one. Then this is all cyclic operators, unary function for using ternary inverters. Why this is 27? Because here is 3 to power 3 total number of state. In binary, 2 to power 3 means total 8. Here is 3 to power 3, 27 number of state. Here is circuit diagram of x2, x1, x. I think it will not necessary to explain, but this is the just like as positive, negative, and also use x2 from this circuits, then generated x2, x1, and x1. All things generated from this value and this value. Why we are using this? Because I need to explain ternary full adder. I have just explained binary full adder, but after using this type of cyclic operator, I need this cyclic operator. Just for binary operators, we need XOR XNOD transmission gate. But for ternary, we need cyclic operator, positive ternary inverter, negative ternary inverter, all things. I've explained 3 is to 1 mux. Here is 1 mux to 1. Here is A, means here is PMOS. When A is 0, this will be on. When A is 2, then negative terminal inverter is 2. When A is 0, then A is 2 because negative terminal inverter is also 2. This time, this path will be on to pass all this value. And when A is 1, means logic A is 1, then for this, when A is 1, then it will pass all value. Here I am using transmission gate, means if logic 1, then pass, if logic 0 is pass. Why? Because I am using PMOS and NMOS. PMOS pass good logic 1 and NMOS pass good logic 0. A0 means this path is on and same time this path will be on. This time suppose that your value is B is 0. When B is 2, then BP is 0. I've explained for ternary inverter. BP is 0 means this path will be on and this time all value of C will be passed. Same thing A1, all value of C pass, and when A is 2, then AP is 0. Why? Because inverter A is higher than AP is 0. This time for this circuits pass all the value for A is equal to 2, A is equal to 2, pass all the value. Here is B and C from this side. This is the ternary full adder I have published in Springer journals. This is the carry circuit, same thing. This is a mux circuit 1, 1, 1. A is 0, why? Because PMOS. A is 1, why? Because A1, then it will be on, and A is 1, then it will be 0. So that's the reason this one is passed. For A2, this one is passed. So it will pass all the values. This is the reason I'm using unary operators. Just explain unary operators, and here is ternary circuits. Ternary circuit 1 and 2. This is the transient response. I've explained transient response in previously using for A0, A1 and B0, B1 and C0, C1. But in ternary circuits, just I've explained previously, A0, A1, A2, B0, B1, B2, for three conditions, three logic, 0, 1, 2, 0, 1, 2, 0, 1, 2. Why we are using different timing response? Because this time for A0, then all combinations of B, for B0, all combinations of C, we get all combinations of A0, B0, C0. Okay? And approximate computing. That's the reason if you want to work, if you're a researcher, a student, you can work on it. Approximate computing, just like I've explained, ternary adders, binary adders. If you are remove any portion in circuits, just like as your ordinal circuits, I have explained, just this is ordinal circuit. If you remove any portions, then my output value will be wrong, not correct, not exact. That's this. Then this whole circuit will call approximate circuits. If either this path, it depends upon whether which path will be critical path, which path will be low. After cutting this path, then output will be low. Approximate computing. Today, there are a lot of portable applications such as cellular phone, laptop, tablets, and notebooks that use image and video processor. It needs low power consumption and higher speed. Approximate adder, multiplier, and other logical circuits can reduce hardware overhead. Why? Because all digital signal processing uses and depends on arithmetic circuits. It is trade-off between performance and accuracy. It is a technique that produces inaccurate results to reduce energy consumption and increase execution speed, but some wrong values. This is not exact. I have explained just previously, all things has been exact. But now I will explain all things has been approximated. Original circuits, some portion has been removed, then approximate circuit and some pruning circuits. Applications of approximate computing, just like image processing, data analytics, media applications, computer vision, robotics, because there is no need of 100% accuracy, and also used in neural network, artificial neural network, spiking neural network, and convolution neural network, in which application there is no need of 100% accuracy, then we can use approximate computing. Why? Because of power consumption and speed. If your critical path, suppose that your critical path will be high, if you reduce this thing, then your circuit will be speed and power will be low. There is error, low, and performance. This is the trade-off between quality and performance. Here is error and performance. Error and performance means if your error is very low, zero, then your performance is better. But if you have generated some error, means 5%, 2%, 3%, then your performance will be high. Why? Because you have cut down your complexities, complex circuits, you have cut down your critical path. That's the reason your circuit speed will be. Comparison of full adder and approximate adder, accuracy high, full adder and approximate adder lower, speed slower, but approximate adder faster, energy efficiency lower and higher, approximate adder higher, complexity higher. But I have cut down the some parts of the circuits, then my approximate adder is lower. Application, general purpose arithmetic, high precision computations, image processing, error resilient computing. Same, I have proposed some circuit, just I will explain in brief. There is a logic I've explained ABC in and carry out and sum in just I've started this lecture, then I just explained. When a both is zero, then output zero. In both is high, then output high. But for approximation, you have just cut down some portion of the circuit. Then your output, some portion will be wrong value. Just for approximate one, I will explain next slide. Two wrong value, two wrong value, one, two, four, and four wrong value. Why? Because your power consumption will be low and speed will be high. So that's the reason I have cut down, I have removed some portion of this original circuits to use for error tolerant application and image processing applications. Here is using a multi-bit just like at 8-bit 0, 1, 2, 3. But main important thing is I have not approximated all circuits. Just I have explained in previously for 32 bits, all full adder. But here I am using approximate either this one, other either this one or other one. Minimum we can use value four value. We have taken four value. But if your value taken higher, then your output will be wrong value because for MSB and LSB, LSB depend on initial value, but MSB depends all four circuits. That's the reason we have taken approximated only LSB side, not MSB side, and not carry circuits. Why? Because carry has been propagated. So that's the reason if your carry will be wrong, then output will be wrong. There is existing adder, just I've explained one purpose circuit and another. Also, it will be used XOR and XNOR bit. But if either I will remove this portion because this is the C in bar C in means one inverter stage has been removed. So when you remove one inverter stage, then your output will be wrong, true value, and your power consumption will be low. Same thing, just in previous, I have cut down this circuit, and this time I have cut down this circuit. Same two value will be wrong. Here two value will be wrong, and here two value will be wrong. And same if I remove whole portion of sum, because I know sum has been taken value from this side. I have taken sum directly COD. Then I have two wrong value. This one and this one. Same condition. I am cut down this value, but this time I have taken sum from XOR because XOR logic, if A and B is high, then XOR will be low. So total four value will be wrong. And still similarly for 5, I have taken value A to A bar, sum from taken from A bar. Then I will also total 4 value will be wrong. So my power consumption will be low, but this is not exact circuit, some error circuits. After that, I'm using matrix approximate computing, error calculated by using MATLAB and PSNR, peak signal noise ratio, also calculated in MATLAB. After approximating, using that logic, using for image processing and taken the value of PSNR using for image blending. Image blending also mixing uh, of two image and to create one image using of approximate adders for this. This is the after using initially real image, original image, but after mixing different value of alpha, this is the approximate adder application. For similarly ternary applications also, this is the ternary. I have just explained this type of circuit, but I have cut down this portion. This portion I have cut down. Just I have cut down this portion here. Sorry, this portion I have cut down. Means cut down this portion means output will be wrong. Here this will cut down, and this portion I cut down in this, then output will be wrong this portion because when this one is passed, then output will be passed some value. But if you cut down this value, then output will be wrong value. After that, why this will be here? After it will also using image processing. Some error has been generated, and after it will be used for image processing. Same logic, I'm not approximated all circuit. I'm approximated either this one LSB this one, or either three combinations, but not for all six combinations. This is the also result of approximated circuit. There is image after combination. This is the different value of alpha. This is the original image. After mixing, this is the approximated image. And value of PSNR is 30 and 32. This is simulation test bench for ternary inverter, ternary circuits using ternary buffer and in output FO4 using a standard ternary inverter. Four inverter in parallelly, four inverter both sides. And main thing that last I want to conclude after this that just I have started to work in this type of work. I'm not more expert in this field. VLSI model for healthcare and safety applications because this time in India also chip design and semiconductor industry is growing fast, very fast. So just using VLSI model for healthcare and safety applications because of cost complexity, compact integration, you can use this type of work for nowadays for VLSI module for healthcare and safety applications. And also same thing, main thing is that hardware and software required. You have used millimeter wave antennas, FPGA board, signal generators, and a spectrum analyzer for soft hardware and software MATLAB Simulink, Cadence FPGA, Toolchain, Vivado, all things used for this type of work. You can work FPGA also using Arctic 7 because mainly paper, research paper comparison compared with Arctic 7 because when word is different, then power is also different because power is dependent on circuits and also on board. This is a feature of FPGA. You can use FPGA for latest research, latest project because this time in chip design, mostly things are fabricated, 10 tape out is used. This is the step of projects because of less time. So actually, I'm sure just want to conclude. You can use FPGA complete design flow using Vivado because Vivado is also easily available all university, all college because student version is also available. So you can use Vivado for another application using very low HDL, VHDL, and you can use RTL to GDS for your project. This is the all flow of Vivado wave and IoT devices also using for ternary applications. This is used for latest ternary application. I will explain because of less interconnection, you can use ternary applications. And this thing of work you can use for healthcare application. IoTs, it is the inner networking of physical device, vehicle building, and another items. Interconnect of everything. So interconnection is more dashed. We can use ternary circuits because of less interconnections. A smart home project you can use for IoT devices. One student also using this time agriculture, just like as for farmers, just using Arduino board. Just farmers actually does not know this time what is the status of his cropping. Just water is high, water is low. You can use IoT devices to monitor agriculture, energy management, and healthcare. Just like as I will explain only one example. Epilepsy disorder. Epilepsy is several neurological disorder where a person tends to experience recurrent unprovoked seizure, just like as for sleeping or issues to migraine problem. So epilepsy is a disease, but VLSI engineer, I'm not a doctor, I'm not more explain about disease, but VLSI design engineer using his data from fusion, from any data source, his data set, and also data set, you can use sleep apnea, two disease. One is epilepsy and sleep apnea. Means suddenly you have sleep. If you are driving car and suddenly you going to sleep, then IoT devices using measurement, blood pressure, diabetes, and depression, all things, your data set, according to a data set, he has taken from any lab, fusion or anything, another thing. So use these things are all things using from FPGA or any other devices. You can measurement, you can design this type of work, devices, biomedical applications for all disease. Main objective of electronics engineer for this type of disease or this type of main sorry, main objective energy efficiency. am to develop an energy efficient seizure and sleep apnea detector. If you want to work on migraine or Alzheimer, anything, your target should be develop an energy efficient seizure and or any other device that operate extended periods without frequently charging. Means your battery backup is high, cost effective. Your cost effective should be low because I just started to work on seizure and sleep apnea detector. But if you want to use any other disease, you can use. But you need data set or all things in Vivado. Highly optimized wearable device, you can use this type of work in your just project or anything other. Using pipelining technique to achieve a high energy efficient and speed high and resource utilization should be minimum because if your resource utilization will be high, then never your power will be low. So these three, four techniques you can use for your designing to low power consumption. This is sleep apnea. I think this time not explained in details. This is also a disease for sleeping disorder. But my work and your work should be also using this type of work. Main this block is important because this is a disease. You can search or look at this. But main work of electronics engineer, you have trained this type of data. Feature extractor, you have used SVM, support vector machine for machine learning application. You have used and all things energy, mobility, all things you have calculated from MATLAB or Python. Then that data you will be explained in an artificial neural network classifier block for you have used and you will be implement on FPGA board or ASIC board to implement on chip. That's the reason this work on MATLAB and Python, and this work after that you will be work on FPGA and use. Just like as example of uh, energy, xi square, you have studied in your signal and system. This type of work, just have explained I is equal to 1 is equal to n value suppose it 1280, 273, depend upon situation, depend upon data. You have squared these things in very low and in MATLAB or Python it will be easy, but in very low you will be explained first square these, then store this value in register. After store, you will be accumulated all things has been stored. Then two register you need. After that, there is output buffer. He stored all the value of the data. This is the Artimon schematic of energy feature. I will explain maybe if I will give any lecture in next time, then I will explain more detail in this because this type of work will be this time continuously mostly researcher doing. So it will be I think interesting topic. Just like as mobility, if you want to explain mobility, implement also this type of data, clock, reset, all things used for in FPGA. And after implementation, this you can explore all the disease, not sleep apnea, Alzheimer, all things you can implement it implemented picture just like as you have defined output for normal patient this data output for apnea or all things your led will be high means you have detected some disease and led is not detected means you have normal patient. This is the next part I will explain in any time. You main objective of the research, you can use various type of adders, exact, approximate, using FinFET, CNFET, and also introduce FPGA implementation of a system for detecting ep- epilepsy and apnea detection for high accuracy and low dynamic power consumption using RTX7 FPGA implementation. Future work, you can use this type of work on ASIC. I'm just explaining FPGA. You can use ASIC in using synopsis, using cadence virtuoso. This will be good for your job, your for research, and your for publication also. Future scope, you can use EEG data set or any other data set used for from Fusion or any other thing, and propose different detectors for different disease and also implement on ASIC on chip training. I'm not this time work on chip training, but you can done on chip training and deep learning, machine learning, all things. This is the references I have taken, and I just thank you. Any question, Dr. Tilak, Dr. Suresh?
Uh, Dear participants, you can ask any doubts, any
Actually,
questions.
I have given the time 5 to 6, but 9 or 10 minutes extend. But my suggestion for participants, you can use this type of work on FPGA, ASIC, or any other tools for high publication and job both. If you're interested in publication or research, then also good. If you want to do a job, then it will be very good for you. Yes, Dr. Suresh.
Dear participants, if you have any doubts, you can ask to sir. I'm going to unmute the participants. So you can ask questions. Now, dear participants, now you can unmute your mics to talk with sir if you have any queries regarding the session, whatever he has given us till now. Sir, you mentioned your mail ID, sir, in the chat box. If they have any doubts, they will
Yes.
post you mails.
Yes, 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 yes. It will be good. Just sure. Yes, sir. Doctor, I have mentioned.
Yes, sir. We have seen. Noted, sir. Thank you, sir. Thank you very much.
Thank you very
for your
much. Thank
valuable
you all
time. We
participants
have
and also Dr. Suresh and Tilak. It will be good. I'm really very enjoying to talk this thing. And if next time, next year, I will try to explore more FPGA ASIC. I think it will be good for new learning, for job and research purpose.
okay, sir. Thank you, sir.
Thank you. Thank you very much.
Thank you very much.
Thank you very much.
Dear participants, the next speaker will be shortly joined in our Google Meet. Yes, stay online.
Good evening, sir. I already joined. Can I share my screen or I will take some time?
Sure, sir. You can share your screen, sir.
Okay, sir. Okay, sir. Please confirm I am sharing my screen.
Okay, sir. Sir, let me make you host, sir.
Sir?
Let me make you host.
Okay, okay.
Sir, now you are the host, sir.
Yeah, visible, sir, visible.
Okay, okay, sir.
Sir. Yes, sir. Is my screen is visible, sir?
Yes, sir. Yes, sir.
Yes, sir, visible.
Okay, sir. Okay. Good evening to the respective participants. Myself, my name is Dr. Kiran, and today I am presenting empowering deep learning architectures with innovative coding approaches.
Yeah, good evening, sir. Good evening.
Right. Sir, is my screen is visible now?
Yes, sir. Yes, sir.
Visible, sir.
Okay.
Yes, sir, visible.
Thank you. My outline of the presentation follows this: AI and interrelationships, machine learning concepts and approaches, classification and examples, deep learning approach, deep learning applications, convolutional neural networks, layers in deep learning, implementation of deep learning without coding, implementation of deep learning with coding, and different deep learning architectures. So here, my main intention is to give the brief about deep learning architectures with coding. So before going to the deep learning, I will discuss some basics about artificial intelligence and machine learning and classification. So it's with everyone, you already know, some of you have an idea about artificial intelligence, machine learning, artificial networks, and deep learning. While you observing the diagram, artificial intelligence is having a broad domain. So generally, humans are having machine intelligence to do the task. Similarly, machine is also having some intelligence to do the task. When machine starts thinking, that is called as artificial intelligence. And the next one is machine learning. Machine learning is the subset of artificial intelligence. Machine learning will support to achieve artificial intelligence. Machines are learning through the algorithms. The next is artificial neural networks. So artificial neural networks is a subset of the machine learning. We know it is inspired from the brain inspired machine learning models about neurons and its connections. One neuron is connected to other neurons. The information processing is done. So similarly, artificial neural networks is also having the same. And the more focusing area is deep learning. So deep learning is the subset of artificial neural networks. So generally, the basic idea of the artificial intelligence starts in the year of 1950. From 1950 to 1970, everyone is thinking about artificial intelligence. The basic idea has been started. Then the idea of machine learning commenced from 1980. So after certain improvements in machine learning, the deep learning comes into the picture in 2010. From 2012 to present 2024 era, the deep learning has very tremendous changes in the research. Many of the areas people they are working in deep learning. So what is meant by machine learning? Just I will discuss the basics. So we know machine learning is the branch of AI. So name itself, machines learns through the algorithms. So machine learning is a general term for computers to learn from the data. When you observe the diagram, the machines learn from the data. So generally, suppose if you're having a data, the machine starts learning the data. So once the machines learned the data, then you can give the new test data for predicting the type of the class. That is the basic idea about the machine learning. So I will tell you a simple example. Suppose there is a human, the task is getting fruits from the kitchen in the top floor. This is the task. So generally the human will go to the house and he entered into the top floor and he will take the fruits. So what happens when you the same task apply to the machine? So here you have to follow some steps. First you have to initialize the machine. Then you can go to the left side. Please see that arrow, see my cursor. So you can go to the left 10 meters and you will found some steps and you can climb for 6 steps. Then you will found the kitchen. Then you will get the fruits. So these type of instructions, algorithmic instructions, you have to give to the machine. So generally, if you are talking about machine learning, we should know about what is meant by supervised machine learning and unsupervised machine learning. Suppose you have a data. If your data is supervised with some label, then it is called as supervised learning. So in case of unsupervised learning, there is no supervision. So based on the characteristics only, you should learn about the data. That is called as unsupervised learning. If you observe the diagrams, so this is for supervised learning. These are the labels. So each and every data, the label has been given. So once you trained the model with the labels, data along with the labels, then you can test with the new data. Then the predictive model will say about the depth. So this is called as classification. Generally, supervised learning is suitable for classification algorithms. The other it is unsupervised learning. So in case of unsupervised learning, there is no label, there is no information about the data. So based on the characteristics, the data will be formed in terms of groups. So these are called as clusters. So generally unsupervised learning is preferred for clustering algorithms, the data which is not having any information. So the brief overview of machine learning. So machine learning, so supervised learning and unsupervised learning. Generally supervised learning we can useful for in classification. So there are different areas, so you can classify. So similarly regression, you can use it supervised learning for the regression. At the same time, other side unsupervised learning. So unsupervised learning, will be useful for the clustering type of problems as well as dimensionality reduction. So apart of this, we have another type of machine learning that is called as reinforcement machine learning. So in case of reinforcement learning, so it is based on trial and error approach. So coming to the standard machine learning approaches, suppose we have a data, either supervised or unsupervised data. So you have to extract the futures from the data. Futures are nothing but useful information. Suppose you have a data, you should extract only useful information from the data manually. That is called as future extraction. So the feature extraction data you are giving to your machine learning algorithm, and your machine learning algorithm will group your objects. So this is called as training. So once training is completed, you can give the new data. The same process will be continued. So for the new data also, it is extracted the same futures, and that futures again it is applied to the machine learning algorithm. Then machine learning algorithm will work as a predictive model. It can predict about the type of the object. This is the standard machine learning approach. First, what is meant by classification? So generally, machine learning and deep learning, generally they are using for classification and clustering and regression type of problems. So first of all, what is meant by classification? So classification is nothing but categorizing different types of data. So here the main objective is to learn mapping from the input futures corresponding to the class labels based on the training set. So once your machine learning algorithm, once your network is trained with the data, then it will automatically predict for the new class labels. If you see the diagram, so this is my data. These are nothing but vegetables and groceries. When you apply this data to your classification model, it may separate vegetables in one side and groceries in the other side. So nothing but categorizing your input data. So one class is vegetables and other class is groceries. So there are different types of classifications. So we have binary classifications, multi-class classifications, and multi-label classification. So I will give an example for about binary classification. So you can predict, we are getting some mails. You are predicting whether your mail is spam or not spam. So that is the example for binary classification. Suppose if you are classifying more than 2 labels, then it is called as multi-class classification. So example is given. We have to classify different flowers. In iris data, we have different categories of flowers. So you can classify more than 2 class labels. So this is also one of the best example of binary classification, classifying credit card transactions, either it is fraud or not. In other side, we have multi-label classification. So binary classification is classifying between only 2 variables. In case of multi-class classification, we have to classify more than 2 objects, more than 2 classes of the same type. If you classify more than 2 classes of different types, then it is called as multi-label classification. If you see the example, suppose if you classify cat, dog, fox, tiger, lion, all are the animals. So here in the right side, cat, dog, tiger, bird, and fish. In between there is a bird. So this is called as multi-label. So in between animals, you have a bird also. If you classify like that, then it is called as multi-class classification. In both types, you will categorize more than 2 class labels. So clearly I will explain. So binary classification. So binary classification is having only 2 classes. So output labels are either 0 or 1. So examples are, suppose if you in breast cancer issues, you can classify whether it is benign or malignant, spam or not spam, fraud transaction or not a fraud transaction. So these type of classifications are called as binary classification. If you have more than 2 class labels, if you classify more than 2 class labels, then it is called multi-class classification. If you observe in these figures, so in between, it is categorizing 2 different labels only. Here it is categorizing more number of classes. So this is multi-class classification. See, some other examples. So binary classification, you are classifying whether it is 5 or not a 5. So your classification is done between only two classes. So here you have to classify 7, 1, 2, 3, 4, 5, 6 different classes. So it is having multiple classes. So that's why it is classed as multi-class classification. We are coming to deep learning concept. So name itself, deep. So deep refers to number of layers. Suppose we have a network. The network is having, initially we have artificial neural networks. So in artificial neural networks, we have only 3 different types of layers. One is input layer, output layer, and hidden layer. So after that, in deep learning, the difference is nothing but you are having, if you observe these two figures, the deep learning neural network is having more number of hidden layers. So simple neural network, it is having only a single hidden layer. So in case of deep learning neural network, it is having multiple hidden layers if you observe. So this red indicator nothing but input layer. So along with input layer and output layer, you have to, so based on your application, based on your data, you have to choose more number of hidden layers. So deep learning, the deep refers to number of hidden layers. So deep learning is also considered as a type of machine learning. So the model learns to perform classification tasks directly from the data. The deep learning directly perform classification tasks from your data only. So deep learning is a kind of representation learning which there are multiple levels of features. These features are automatically discovered. So in case, see, if you observe the image in the right side, so this is the input layer, your data. These are the hidden layers. These are the output layer. So in deep learning, we have only input layer, hidden layer, and output layer. The purpose of hidden layer is nothing but extracting the useful data from your extracting the useful features from your input data automatically. That also automatically. So this is about the deep learning process. So till now we discussed about machine learning as well as some basics of the deep learning. So here I will give you a brief about difference between machine learning and deep learning. You have some input data. So here in machine learning, we have to extract useful features from the input manually. Then after manually extracting the features, you have to learn that features to learning algorithm. Then it will classify. It will classify whether it is a car or not a car. But in case of deep learning, you directly give your input. Deep learning layers automatically extract features from input layer, features from the input. At the same time, the features you can apply to the classification algorithm. Then it will classify whether the given input is car or not a car. So if you clearly observe these two diagrams, here feature extraction and classification done at the same time. So deep learning layers, especially deep learning layers, they are automatically extracting useful features from your data, and the same features it is applied to the classification layer, then finally predict whether it is a car or not a car. So this is the main difference is in case of machine learning, features extracted manually, but in case of deep learning, the features extracted automatically. So coming to the different deep learning architectures. So deep learning architecture further classified into supervised and unsupervised. I already told in the previous slide, supervisor means the data with the label. Unsupervised means data without the label. So supervised learning again classified as convolutional neural networks and recurrent neural networks. And again recurrent neural networks further classified into LSTM, long short-term memory, and also gated recurrent unit. And unsupervised learning classified into two different types, self-organizing maps and autoencoders. So deep learning performance. So when deep learning performance achieved good results, if you observe the graph, so x-axis is dealing with the amount of data size, and y-axis deals with the performance. So if you increase the amount of data, if amount of data is low, machine learning observe this red line. Machine learning algorithm will gives you better performance. So whenever if the data size is increasing, suppose if you have large data, so then deep learning will gives you the better performance compared to the machine learning. In deep learning, the first thing you have to notice is you will have the large data. So if you have a small data, you want to perform a classification task or regression task. Suppose if you have a large data, go for deep learning. If you have a limited data, then go for machine learning algorithms for better results. So what are the applications of the deep learning? So I have given some basic examples. So nowadays Tesla cars, self-driving vehicles. So this project is already implemented in US and UK, self-driving cars, and that is based on deep learning. And one more application is ATM. So ATM rejects a counterfeit banknote. Then and in health monitoring, wearable devices, we can use deep learning. So deep learning has many applications. So you can use it in image recognitions, chatbots, marketing research, translations, data science, whatever it is. So you can apply it anywhere in deep learning. So here I have mentioned some applications in deep learning and VLSI technology. One is design automation. So generally deep learning models, GANs, generally they are used to generate optimized layouts for VLSI circuits. Nowadays, NVIDIA is using deep learning in automation, in design automation. And the second thing is fault detection and diagnosis. So in this, you can use convolutional neural networks and placement and routing. So in placement and routing, you can use reinforcement learning. So these are very new techniques. If you are interested in VLSI side, you can, if you have a knowledge in deep learning, you can apply your deep learning knowledge in VLSI technology. So deep learning you can use in any areas. You can use in signal processing. You can use deep learning in communications. You can use deep learning in VLSI. You can use any domains in any other mechanical engineering, civil engineering. You can apply. So based on your problem, you can apply deep learning. So now I will move to convolutional neural network. So generally, deep learning will starts with CNN generally. It is the most popular deep learning for images. So generally, deep learning initiated with only starting with the images. So then two-dimensional data. Then deep learning implemented for one-dimensional data as well as three-dimensional data also. So in convolutional neural networks, it is having input layer, output layer, and many hidden layers. If you see the bottom, this is a CNN network. So this is your input layer. So in between many layers. So these layers are for future, they are called as future learning layers. And the last layers are called as classification layers. So we have different layers in future learning. So you have convolution layer, you have pooling layer, you have flattened layer, you have fully connected layer, and you have softmax layer. We have all these combinations called as convolution neural networks. Next, we have a concept of transfer learning in deep learning. So generally, before go to the customized deep learning, we can use the concept of transfer learning. So fine-tuning a network with transfer learning is usually faster and easier than training network with randomly initialized weights from scratch. So generally, we have suppose we have different layers. Each layer is connected with other layers with weights and biases. So suppose if you initialize weights from starting, that is from scratch, it is very difficult to train your network. Suppose if you use some other networks, so then it is called as transfer learning. See, if in bottom I have given the methodology. So we have a pre-trained network, suppose. So pre-trained network means somebody they have developed one deep learning network. So they have initialized their weights. So you can use their network to your application. So here you have different layers of the deep learning. So in suppose if you are working with pre-trained models, you have an option to change only the last layers. So you have so you can replace the last layers. So last layers are nothing but classification layers. So you can change the classification layers based on your parameters. So don't touch the before layers because these layer weights are already pre-trained. So then once you replace your layers, then you can train with your images. Then you can test your network. So briefly, I will explain. So transfer learning is nothing but you have a data. So some pre-trained CNN networks are available. In right side, you will observe AlexaNet. These are already trained with some outside images. VGZ, GoogleNet, ResNet, SqueezeNet. So these are nothing but so year-wise they have implemented MobileNet, GoogleNet, DenseNet. So these are called as pre-trained convolutional neural networks. So pre-trained means so this networks is already trained with some images. Suppose you have an application, you can use their network based on your application. So in that you have to replace the final layers and you can give your data. You can give your data to pre-trained CNN. Then you can train your CNN with your images. Then you can test your with the new task. Then it will say whether it is a car or a truck, whatever it is. So based on your application, you can choose different types of pre-trained models. So coming to the layers in CNN. So in convolutional neural networks, we have different types of layers. So one is convolutional layer, and the next one is pooling layer and fully connected layer. So these three layers combination will called as convolutional neural network. So you will have one-dimensional convolution layer as well as two-dimensional convolution layer, and pooling layer also you have two different types: max pooling layer and average pooling layer. We will see the significance. First, what is convolutional layer? So convolutional layer, so generally scientifically we will call as a convolutional filter which maps your input at a particular area. Suppose this is your filter, convolutional filter. It will maps with your input data and it will gives you a output, corresponding output. Convolution, suppose you have a digital image, 6x6 image. You have a convolutional filter. So here filter 1 and filter 2. So this is the filter of kernel 3x3. This is also filter kernel with 3x3. Here my 6x6 image. Suppose this is my input data. Input data is applied to convolutional layer. We will see what happens. We will see. So this is my convolutional. This is my convolutional filter. 3x3 convolutional filter. I have to map to the input image. So this is my 6x6 binary image. First portion is mapped. Then you have to perform the dot product at the same position. 1 into 1, 0 into -1, 0 into -1. Same positions values will be multiplied, dot product. So you are getting 3. Suppose this is stride 1 means your mapping area will move to only one position right side. See, now it is mapped to this portion. Again, you can perform dot product 0 into 1, 0 into -1. The final answer is -1. After performing dot product, you are getting -1. Similarly, suppose if the stride is 2, what happens? Your filter mapping moves to 2 positions to the right. Please observe. So this is the mapping position with the kernel filter. See, now it is mapped to 2 positions from the first call. Perform dot product. So stride 1, first dot product, second, third, fourth, fifth, right. Like that you have to perform. So this is your convolutional future map. Second filter. Repeat for this each filter. first position, second, third, fourth, fifth. So like that you have to perform with the second kernel also. Do the same. This is called as future map. From the after applying to the convolutional layer, convolutional filter, 3x3 convolutional filter. See, here you can observe your 6x6 image. When your 6x6 image passes through two different convolutional filters, your feature map size is modified by 4x4. 6x6 is converted into 4x4 after applying convolutional filter. Then pooling. So what is meant by max pooling? Now these are your future maps from convolutional layer. Then you can apply max pooling. So pooling is nothing but it is also called as downsampling. 2x2 pooling. Max pooling means in that area you can choose the maximum value. Here maximum value is 3, maximum value is 0, maximum value is 3, maximum value is 1. Similarly here, for the second filter, maximum value is 1, maximum value. See what happens when you're applying pooling. So just now I told pooling is nothing but downsampling. So suppose this is my input image. When I applied pooling, then what happens? Your image size is reduced, but the original information is not changed. So that is the advantages of pooling. See convolution and max pooling. So this is your input image. Your applied input image to the convolution filter. After max pooling filter, after that your image is transformed to 2x2 image. So 6x6 image downsample to 2x2 image. So now convolution pooling. So these types of blocks in, suppose if you want to work with convolutional neural network, these blocks will be repeated: convolution, pooling, convolution, and pooling. These layers repeated many times. Convolution, pooling, new image, convolution. So this image I already told you, this image is smaller than the original image. The number of channels is the number of filters. So then after flattening, so you got 2x2 image. So now still you have two-dimensional data. You have to convert your two-dimensional data into one-dimensional data. Then I can use flattening. See these orange color samples at the top and these blue color samples at the bottom. So now your 2x2 is converting into into a single array. Two-dimensional data is converted into one-dimensional array. Then after converting into one-dimensional array, you can apply it to the fully connected network. So this is one type of problem, one example, cat or dog. So first you can give an image. You can apply different blocks of convolution and pooling. Every time you're getting a new image. So after repeating this multiple times, so then your image is flattened. Then flattened means it is a one-dimensional array. One-dimensional array, you're giving it to the fully connected network. In fully connected network, each and every neuron is connected to all other neurons. This is then it will classify. After that, it is classified whether the given image is cat or dog. So this is the basic methodology in convolutional neural networks. Suppose if I work in keras, so I will show you along with coding also. So convolution pooling, then flattening, then fully connected, then classification. So this is the methodology process. So now you can use keras library for implementing CNN. So here convolutional 2D, this is 25, it represents the number of filters. So 3x3 is nothing but kernel size. This is 28x28. This is your input image size. Suppose this one represents, it is a black and white image. Right. And suppose if it is a color image, you can use it 1. So then max pooling. So 2x2 pooling. So 2x2 means once your data is processed from convolutional filter, then it gives to max pooling. 2x2 means 2 by 2 space. So in max pooling means in that 2 by 2 elements, it can choose only the maximum element like this. It will, so here the maximum is 3, it will choose 3. So now, suppose your input size is 28 by 28. After applying convolutional layer, your input size image is reduced to 26 by 26. So here the 25 represents the number of filters. So after pooling, then what will happen? Further, your image is reduced to 13 by 13. So then again, you're applying convolutional 2D filter with 50 filters with a 3 by 3 kernel. Your input image is further modified 11 by 11. So then after pooling, it transformed to 5 by 5 image. So original image size is 28 by 28. After second max pooling, your image size is reduced to 5 by 5. So then is flattened. So 5 by 5 means 5 into 5, 25. Sorry, 5 into 5 into 50 channels. Total 1250 elements. You can apply the same to fully connected feed-forward network. Then it will classify the output. So this is the methodology in CNN in Keras. So now you can implement deep learning architectures without coding also. Those who are beginners, those who are not interested doing coding, then you can use these type of softwares. So you can implement deep learning and machine learning techniques without coding also. I will show. So the first is nothing but Vika software. So I think many of you familiar with this Vika software. So Vika software generally started in 1990 by the University of Waikato, New Zealand. So in Vika platform, this is the backend software is Java. So now for some algorithms, the backend software they are using is Python also. So you can implement different machine learning algorithms. So Vika will have in right side you can see you can use Vika for pre-processing your data, classifying your data, clustering your data, visualization of data samples, selection of different attributes. You can use it for different applications. In machine learning, you can visualize your data. In right side, you can observe by using this Vika software. You can observe. This is just a geo interface. Just type Vika in your Google, and you can you will have one application. You can install that application. So you need only the data, either ARFF format or .csv format. Data with the label. Your data with your label. Then you can export your data into the Vika software. In Vika software, you have different pre-processing algorithms, different classification algorithms. You can choose any one of the algorithm. Then, without programming, it will generate the results. In right side, you will observe some classification results. The classification parameters it will give. So you can use Vika software for classification, clustering, regression. So Vika is having more than 20 machine learning algorithms. So those who are beginners, those who are interested to work in machine learning or deep learning areas without coding, you can use Vika software. So similarly, we have another software that is called as Orange. Generally, Orange is used for data mining. Now EC people, you are familiar with the software called as Simulink and PSPUS, drag and drop type of options. So here in Orange also you have drag and drop type of options, nothing but a signal flow graph. So here it has different blocks. You can arrange blocks as per your requirement. You can connect those blocks. You can give the data and you can observe the outputs. So Orange also in Orange software also you will work with you will found different machine learning algorithms, and you can visualize your data variables also. You can implement different machine learning algorithms. In right side you can see SVM, classification trees, nearest neighbors. You can apply different algorithms in Orange software. This is also without coding. You can perform all these things. You can generate the results. So many researchers are working in Vika as well as Orange. You can publish papers. You can mention these softwares. So now with coding also we can implement deep learning concept. So generally machine learning or deep, we have so many software. Suppose you can use MATLAB for deep learning, to implement deep learning. We have Python also. So generally, many of the researchers, they are using Python because it is an open source software and updated. That's so these are the important. Suppose if you have any classification problem, suppose if you use Python, you have to follow all these steps. So first you have to understand about the structure of the input data. Then so once you loaded the data, then you can apply different pre-processing techniques. Then you have to identify the number of classes. Then you have to identify in Python. Python is nothing but package based, right? So you can so based on your requirement, you can import different packages. Then you can experiment with different architectures. So once you finalize your architecture, you can tune its parameters. So hyperparameters tuning is very, very important in deep learning. So what are the necessary steps you have to perform before doing Python coding? So first you have data set. First you have to divide the data set into training and testing. Generally, in our data, majority of the percentage we are using for the testing, and remaining percentage you are using for training, 80-20, 60-40 or 70-30, right? So then after that, you have to train with the training data. Once you choose the learning algorithm, then you trained with your algorithm. So then you have to test with the new data set. Then you will identify the performance metrics. So here you can split your data set into training and testing. First you have to train your model. Then you have to evaluate your algorithm with the new data that is called as test data. So here in deep learning, only two blocks. One is pre-processing. So generally pre-processing is a basic step. Suppose if your data contains any noise or artifacts, any contaminations, any contaminants, then you can remove all those things. So once your data is ready, then you can apply directly to the deep learning algorithms. I already told you deep learning is having automatical feature extraction and classification. So here for deep learning implementation, you require different packages. So you should have pandas, NumPy. I think some of you familiar with some packages. Pandas, if you want to manipulate the large data, you can use pandas. NumPy, you're working with the numbers. And sklearn model, suppose if you want to work with machine learning algorithms, you can go with sklearn. Then Keras. So Keras is a powerful tool for importing neural networks and as well as deep learning layers. And TensorFlow. TensorFlow is also one of the package for deep learning, so which is implemented by Google. So suppose if you have work with complex architectures, then you will go with the TensorFlow. Otherwise, you can implement deep learning with Keras. So at present, Keras is integrated with the TensorFlow. So now I will move to different architectures. So what are the architectures available in deep learning? So left side you will have a Python program. So first you can import different packages for deep learning. So just now I told you can implement Keras layers from Keras layers. So this is called as multi-layer perceptron. In multi-layer perceptron, suppose in artificial neural network you are having one input layer, one output layer. In between there are hidden layers. If you are having more than two hidden layers, suppose if you have 3 or 2 hidden layers, then it is called as multi-layer perceptron. See here, we have implemented different layers using Python programming. These are dense layers. So this red color will shows different hidden layers. So I have summarized these architectures into a form of the table. So input layer. So these are the output shapes. So each and every layer, what happens? Once you process from one layer to output layer, what happens to your data? Your output shape is given here. So then parameters. So parameters represent number of weights and number of biases in your layer. So this is the graph of your multi-layer perceptron. All these I have generated from the Python coding. So here input layer, dense layer, dense layer, dense layer. So we can call in fully connected layer, we can call it as a dense layer. So the next is convolutional neural network. So first you can import different libraries. So here I have taken an input image of 64 by 64. This one represents the black and white image. Here I have implemented, I already told you, convolutional neural network is the combination of convolution layer, pooling layer, repeated multiple times, convolution pooling, then flatten. So each and every convolution layer, you can specify the activation function also. Here my activation function is reloop. Generally, activation function will activate your neurons in each layer. So then flatten, then dense, then this is the classification layer. Dense with sigmoid. Sigmoid is nothing but this is one of the good activation function for the binary classification. In the right side, you can observe the summary of the convolution neural network. These are the output shapes. See, current input layer inputs in image size 64 by 65. After applying the first convolution layer, your image size is changed to 61 by 61. After pooling layer, half of the size is reduced. I already told you, max pooling layer is nothing but downsampling, downsampling your data. So right side, you will observe the summary graph of the convolutional network. Input layer, convolution pooling, flatten, dense, and dense. The last dense is nothing but the classification layer. It may classify whether your image is corresponding to which label. So this is the recurrent neural network. In recurrent neural network, the example is long short-term memory. Here I implemented long short-term memory. LSTM layer. Here LSTM layer. You can use by LSTM layer also. Or you can use GRU layer also. Then dense and dense. Finally, your whenever if you see any LSTM layer in between the network, then it is tends to relate it to the recurrent neural network. So in the right side, you will observe the image, input layer, LSTM layer. LSTM layer corresponds to the recurrent neural network. So in convolutional neural network, I have not, it should not contain any memory. But in case of LSTM network, it is having a memory. Generally, this recurrent neural networks used for time series prediction, weather prediction, time series prediction, a sequential data. Suppose if you want to predict the continuous time, then you can go with LSTM networks. Now we have followed with different architectures. Shared input layer. Now you have only one input. Here with one input, you can have different feature extractors. Here you can use convolution and pooling. Flatten, this is for one feature extractor, and this is for another feature extractor. Convolution, pooling, and flatten. So right side you will observe your input layer is shared with this network and also with this network. So after flatten layer, you are getting your features. The features are concatenated. So single input, this network is achieving one type of features and this network is extracting another type of features. So all these two features you are concatenated. So then apply to a fully connected network, then you can classify. This is one type of architecture you can use based on your problem. The next is you have different input layers, multiple inputs. How can you work with multiple inputs? Suppose this is right here, you can observe this is one input layer, one image, this is other image. You can apply different CNN architecture here. Here apply another CNN architecture for another image. So finally, you are after flatten, you are getting extracted features from the network 1. Here you are extracted features from network 2. Finally, these two are different features. These two are concatenated. Then you can apply dense layer. Then you can apply dense layer. Then you can apply this dense layer for the classification. So here you can work with multiple inputs. Extracted features are concatenated. So you can classify. So until now I have given some basic idea about deep learning. So deep learning and machine learning, and I have also given idea about coding techniques and without coding. Those who are the beginners, those who are interested to work in deep learning. So those are beginners. So my suggestion is you can go with without coding softwares. You have Vika software as well as you have Orange software. So those who are interested in working with deep learning, somewhat familiar with Python, then you can work with deep learning using Python architectures. So if you are interested in working with Python, we have both online software as well as offline softwares. So you can offline software means you can go with if you are beginner, you can go with Spider IDE. If you are somewhat familiar with Python, you can go with Jupyter. So suppose if you are very interested working with online tool, then you can go with a Google Colab platform for applying different deep learning architectures. So thank you. So if you have any questions, you can ask.
Dear participants, if you have any queries or questions, you can ask to sir. Sir, just a minute. I'm going to unmute the participants so that they can
Okay.
ask questions directly to us.
Okay.
Dear participants, if you have any queries, you can ask to sir, Dr. Kiran Kumar Patra. Sir, I have one doubt, sir.
Please, sir. Please carry on. Please continue.
Actually, recently I have joined in PhD, sir.
Fine.
In antennas domain. Actually, my area of interest is antennas domain. Actually,
Okay.
I have heard that machine learning and algorithms can be implemented to antenna design. How it can be related and how it can be connected.
Sir, so first of all, what is your task? That is important, sir. So in antennas is a broad domain. We have different tasks in antenna domain. Which so suppose if you want to optimize any parameter, suppose if you want to classify any parameter. So based on your task, you can work with either machine learning parameters or deep learning parameters.
Okay.
So based on your task.
Sir, and I have one more doubt, sir. Suppose I'm going to concentrate to minimize the one of the parameter in antenna designing.
Okay.
Okay. So based upon the model and based upon the method, if I mention the sentence and if I put it in the chat GPT, is it give solution for me, sir?
Sir, please once you can repeat.
Suppose I would like to optimize one of the parameter in the antenna designing.
Okay.
Now, if I put the sentence in the format of sentence in the chat GPT, can it shows the solution for me so that how I can optimize by using what method like that it will show?
Yes, sir. Yes. Chat GPT is also one of the application of natural language processing, deep learning, sir. See, sir, it is also working with AI. So you can clearly give the input, sir.
Okay, sir.
Suppose if you are asking a question to human, so how you are asking the question to human, similarly you can give the same to the machine also, chat GPT. You can clearly mention what is your task. Suppose in this antenna, in this error factor, in this parameter, I have to optimize what type of algorithms in machine learning or deep learning. Like that you can type, you can give a proper prompt, then only you will find different solutions. Chat GPT is really helpful, sir, for writing the codes in Python and other languages also. You can use ChatGPT also.
Okay, sir. Dear participants, if you have any queries, you can ask to Dr. Kiran Kumar.
Sir, good evening, sir.
Good evening, sir. Good evening.
Yeah, actually, your presentation was very nice. We also gathered many things from there. I have a small doubt in it, sir. Sir, whether these parameters can be able to implement in FPGA, sir? This result we can able to implement in FPGA?
Sir, so just now I told that based on your problem, first you can choose your problem. In FPGA, what is your problem? You can detect, suppose you are detecting fault detection or routing or...
Yes, sir. As you said, we can use Python and MATLAB also.
Yes,
So
sir. Yes,
from
sir.
that we got an output. Now that output has to be implemented in the PGA. Is it possible?
Yes, sir.
So
Definitely.
we have a parameter, sir. Actually, the parameter is mentioned as a either voltage or it's a numerical value.
Okay.
Whether that, yeah, based on that value, we can write the code for Verilog or VHDL.
Yes, sir.
Then we can implement in FPGA. It's a normal procedure. But as you said, you have a software is called Python. Then
Yes.
we got a result from the Python.
Okay.
That result we can able to implement with the help of FPGA. Based on that parameter, we can write the
Sir, yes, sir. Yes, sir. I understood your question. So
yeah.
generally, in case of FPGAs, you can upload with only VHDL or Verilog codes only, sir.
Yeah, yes,
Generally,
sir. Yeah, yeah.
sir.
See, in the end of the Python or MATLAB code, we have a parameter, sir. That parameter again we try to implement or convert with the help of FPGA as well. Sorry, Verilog or VHDL. Then we can think about the implementation part. Is there any provision to do this kind of conversion?
Yes, sir. Yes, sir. There is a provision for. I think there are some FPGA boards, some boards, Raspberry Pi and Arduino. So
Yeah, yeah.
these boards they support Python also. So directly Python and some STM microcontrollers. These type some boards are there. So these boards it
Oh,
may
that is we have to use separate ports
yes,
for
separate
getting the
boards.
inputs.
Yes, yes, yes.
Okay.
I think there are some interfaces are there, sir. You can just search on that interfaces. So these interfaces may convert from Python language to VHDL maybe. So then you may upload it into the FPGAs, respective FPGAs.
Okay. Thank you, sir. Thank you.
Mm. Sir, we have a questions in chat box. One participant, Sashita, asked about can we apply CNN for signal processing? Yes, yes, you can apply for CNN. Generally, we have in signal processing, we have one-dimension signals like in healthcare domain, ECG, EEG. So these type of signals are one-dimension signals. You can apply one-dimension deep learning architectures in one-dimension signals also. So we have one-dimensional convolutional neural networks also available. And one more question, what changes happen in original image to the transformed image? So just now I told, so whenever if you apply uh, any convolutional filter, your input image is transformed. So generally convolutional networks is trying to extract useful informations from the input image. So that is happening. So in case of machine learning, uh, manually we can extract useful informations from the inputs, but in case of deep learning automatically it will extract the useful information from the image. Suppose suppose a single image is there, single image only bird is there, so the portion of the bird is important, suppose, so remaining portion is not important, suppose. So what happens in deep learning is, so in case of deep learning layers, it may extract only the useful information from the image. So that's why your image is transformed from one dimension to the another dimension. On what basis we can select the kernel? So this is a good question. So based on your input size, you can choose the kernel. Suppose your input size is very large. Suppose you are taking 150 by 150 image. Suppose you are having 225 image. So based on the input size image, you can choose different types of kernels. We have 3 by 3 kernels, 5 by 5 kernels. So based on the input only, you can choose your image. And how can we get useful information? Right. So once it is processed, uh, so once you, so in deep learning, so one thing is very important, that is hyperparameters tuning. So after extracting the features, you may give different trials, you may do different experiments for getting the best classification accuracy. Suppose if it is not getting best classification accuracy, you can change your parameters. Sir, I think I have answered all the questions. Sir, any other questions from the participants?
Dear participants, you can ask questions to sir.
Sir, I will give you my mail ID in chat box.
Okay, sir. Okay, sir. Sir, one more question.
Yes, sir, I will answer.
Okay, sir.
I will typing the mail ID. One more question, that is why two kernels selected? Just for the demonstration purpose only, I have chosen two different type of kernels. So here you can randomly suppose if you choose 3 by 3 kernels, so randomly it will select first point. The difference means randomly it will select. Randomly it will select. So if you choose 3 by 3 kernel, so 3 by 3 portion, so total 9 elements, randomly it will have. Difference between kernel one, there is no such difference between kernels. Any other questions? Participants, I have given my email ID. So if you have any queries, so I have also have collaborations also. If you are interested to work with me, you can just give a mail. If you have any question, if you have any clarifications regarding deep learning architecture in any area, you can just mail me. I will revert you back. Thank you.
Thank you, sir. Thank you very much for sharing your valuable information to us, sir, in this ATAL FTP session, sir. Thank you, sir.
Thank you, sir. Thank you.
One more request, sir. Sir, I request
Please.
everyone, all the participants are on your videos so that we can have one pick.
Okay, sir. I will switch on my video.
Dear participants, just a minute. Thank you, sir.
Thank you, sir. I thank the ATAL FTP coordinators. Thank you for giving me opportunity. Thank you. Thank you all.
Thank you, sir. I request all the participants on their videos once. I request all the participants requested to on their videos for taking a pic. That's it. Okay. I'm going to share the test link in the group, in the WhatsApp group. Just it is a which includes 30 MCQs. Okay, and one more, and we will the certificates will be issued within 3 to 4 days. Participation certificates will be issued. Okay, and thank you very much. And during 6 days, we have learned a lot of research information from various professors from both IITs, NITs, and universities, different universities. Thank you. Thank you, one and all, for participating in the ATAL FTP based upon the recent research trends in VLSI technologies and antennas for 5G. Thank you very much. Thank you. I'm going to share the test link. You can take test which includes 30 MCQs. Thank you very much.